dive right into
Yeah,
it? Or are you going to say anything?
yeah. Welcome everyone. Welcome again to our Java Online Talks here in Riyadh Java User Group. Here in Riyadh Java User Group, we welcome everybody around the world to join us and watch our talks, and also invite all the speakers around the world. Today we have a special guest that we've been really uh, happy to be with us. We have Josh Long. Hi, Josh. How are you?
Hi, good morning, good afternoon, good evening. I'm glad to be here. Thank you for the
Thank you.
opportunity.
Thank you so much for accepting our invitation. Before we be heading to the talk, so let me give brief introduction about our guest. Our guest is Josh Long. He is the Spring developer advocate. Of course, that he's a well-known speaker, author, book author. He's really around the world speaking about Spring, advocating Java, all the sort of languages and sort of technologies. So before we start, we'd like you guys and our audience to join our questions and sessions here. Drop your questions in the comments below. If you have any questions, we'll be happy to answer them. And the stage is yours, Josh. Good luck.
Okay, good morning. I appreciate that. You actually just half a second. Okay, yeah, good morning, good evening, good afternoon. Hi, everybody. My name is Josh Long, and I'm very, very, very happy to be here with you today. I work on the Spring team. I am a Kotlin Google developer expert and a Java champion. And most embarrassingly, I'm a YouTuber. So if you are on YouTube, you can find me here. If you don't use YouTube, then I don't know how you are watching this video. But if you really don't use YouTube and you're somehow watching this, you can also email me, right? I have email. I also use the Bird website, so you can find me there. Look, my friends, I was really thinking about this. I wanted to show you the latest and the greatest and some of my favorite features in the wonderful world of Spring, but I wasn't sure how to do that because there's just a lot, And I thought, well, maybe we could look at the old pet clinic, Spring Pet Clinic. That's this one right here, right? This is a sample application that has been in Spring for a long time, right? Spring is getting to be, it's very mature, right? If you look at spring1.io, history of Spring, you can use this at home. Spring1.io, history of Spring. It's a game, right? So you go to your browser, hit the space bar, and you can kind of see, in 2002, the book introducing Spring was released, the first one. And the project is old, so 2003, their open source project, 1.0 GA 2004, and then you just keep playing the game, and you can see there's all this cool stuff. We released Spring Boot 1.0 10 years ago, so it's been 20 years since 1.0 GA Spring Framework, and 10 years since Spring Boot 1.0. And now here we are in the cloud, Spring Cloud, you get Spring Cloud Task, you get Spring Cloud Stream, Spring Cloud Data Flow, and now you go down here and you're in the water, right? Maritime, navigation, Kubernetes, this kind of stuff. Spring Cloud Data Flow for Kubernetes, Spring Cloud Skipper, Spring Cloud Gateway, and then of course the modern era. Starting in 2022, we have Spring Boot 3 and Spring Framework 6, which enable to natively compile applications to run in Kubernetes and all that. So, basically there's just a lot of cool stuff. And one of the cool things that we have in the ecosystem, like I say, is this Spring Pet Clinic application. I'm sure you've probably seen it before, or at least heard of it. And it's changed over the decades, but this was originally created as a sample application to show Spring Framework code back in 2004. And it's grown over time, and it's very big now. It's very comprehensive, lots of moving parts and features. So I thought, well, I don't want to show. I mean, it's just a lot, right? It's a lot of moving parts. It's too much. So I thought, what could we do to really show something quick and easy, but without that extra sort of complexity? And so I thought, well, what if we did something to help adopt animals, right? I have a dog, for example. Animals are I think a lot of people like animals. What if we helped adopt animals? I have a dog. My dog is he's not a good dog. He's I think he's just a very naughty dog, and he kind of reminds me. My dog's name is Peanut, right? And he's terrible, like I say, and he kind of reminds me of this dog. There's a person in the pandemic in 2020 or 21. They put out this ad to try and find a new home for this dog that she had, and she says that the dog is not a very good dog. She says, um, let's see, right. She says there's not a very big market for neurotic, which means very nervous, very scared, very paranoid, man-hating, animal-hating, children-hating dogs that look like a gremlin. Gremlins are like a monster, right? And the name of the dog is Prancer. Prancer, not a very good dog, very very bad dog, the whole it's very funny. You read the whole thing, it's very very funny. But basically, the dog sounds like it would be a lot of trouble, to have this dog. But still, she wants to find a good home for the dog, even though the dog is like a haunted Victorian child in the body of a small dog that hates men and children, right? So it's a very, very hard to love dog, but she still thinks there's somebody out there that will love this dog. And it's kind of cute, sort of, a little bit, I guess, And so this reminds me of my dog, right? My dog is very, very bad, very, very naughty. But he is kind of cute, right? Here's my dog. His name is Peanut, like I say. So he's cute on the outside, but evil on the inside. And so I think even bad dogs, they deserve a loving home. All of our creatures deserve to be cared for. And so I was thinking we could build like a service to allow you to adopt a dog, right? So let's do that today, okay? We'll build something small and simple and demonstrate some of these cool features with that goal in mind. Now, friends, I've already got a database here, right? PG password equals secret P SQL U my user H localhost my database, right? Log into there, and you can see I've already got a table called dog, and there are different dogs in here, and there's Prancer down here, right? Prancer is a demonic, neurotic, man-hating, animal-hating, children-hating dogs that looks like gremlins. So this is exactly what's in the advertisement from 2021. Okay, and so we want to build a system to help people adopt dogs, okay, or animals, but in this case we'll talk about dogs. And so we're going to go here, as always, to my second favorite place on the internet, start.spring.io. My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the children, bring your family. The weather is amazing. It is the happiest place on earth. It is better than Disneyland. I love production, and you should love production. So if you haven't already been to production, you can start your journey here at start.spring.io. And so we're going to create a new application. We're going to give it a group name and then an artifact name, okay? I'm going to call this new service that we are building, I'm going to call it service. And the reason I'm going to call it service is because I'm amazing with names. I get that from my father. My father was very good with names. When I was a small boy, we had a small white dog, and my father named that dog White Dog. That was his name, just White Dog. Very good with names. Again, I get that from my dad. So I'm gonna name this service, and then we have some choices that we have to make, my friends. First of all, what version of Java should you use? Well, it is 2024, so really anything less than Java 21 makes no sense at all. It's completely unacceptable. Java 21 is the technically superior version of Java, right? It's faster, more syntax rich, more secure, more operations friendly, more performant, and just a generally nicer experience all around. It's also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Use at least Java 21 and later. Now, friends, we have to add some dependencies here. So I'm going to bring in the GraalVM native image support. I'll bring in the web support. I'll bring in the Spring Data JDBC support. I'm going to bring in a SQL database with an extra plugin to support vector storage. Okay, so it's a Postgres with vector capabilities. Okay, so we're going to add that. I want help making my code base modular. So I'll bring in Spring Modulith, and then of course I also want Docker Compose support. I've already got a SQL database running, but if I didn't, I can add Docker Compose to the build, and the Spring initializer would give me a Docker image for my PG vector container, and it would set up the username and password and so on. That's what I did. That's why I already have a Docker image running. So I don't need to bring this in, but you should know that it's there. Also, if you use test containers, right, for testing against Docker images, it's very, very useful. You can do that here. You can see that we create a PG vector Docker image for you in your Java test as well. So either one of those is very good, but I already have one, so I won't use those. GraalVM native image, web, Spring Data JDBC, vector, Spring Modulith. What else? Oh, you know what? I want also to have some intelligence in my application. It's hard to find intelligence in this world. And so because it's so short and so little a supply of intelligence, that nowadays we have artificial intelligence. And so we'll add this. We're going to add OpenAI. But there are many different AI models that you can use. And Spring AI, the project that we'll look at, supports many of them. One of my favorites is Ollama. Ollama allows you to run models locally on your local machine. You don't need to pay anybody. You can just run a model. And so, for example, if I do this, I go here, Ollama run llama 3. Okay. Open this up and let it run. So now I'm logged in, and I can say, I can ask it anything, right? I'm not paying for anything. This is just running on my computer. So I can say, write a poem about the amazing Java and Spring developers in Riyadh. Okay, and please write the poem in the style of famed children's book author Dr. Seuss. Thank you. Right? It's always important to be polite. So I asked it. I just wrote that. Right? I type that into my local machine. This is not over the network. If I want to, I can take off this computer from the internet, and then I can do this, and it'll all work. It's completely private. It's completely open and free. I can run it locally. So in Riyadh's land of sand and sun, where tech dreams are just begun, a group of coders, clever and bright, worked magic with Java and Spring in sight. Their fingers flew across the screen as they crafted code that was supreme, with annotations and frameworks so fine. They brought forth apps that truly shine. And forgive me, I'm not very smart. How do I pronounce that? Kaladia? I hope. I don't know. I'm sorry if I mispronounced it. In Kaladia Street, where innovation reigns, these developers plotted their coding games with each new feature a work of art, Spring magic infused right from the start. You get the idea, right? You can do amazing things, and this is completely offline. So you can use that as well. But I am going to use, and you can also use, Hugging Face and a bunch of other models. But I am going to use OpenAI. Okay, you have to pay for this, but it works very nicely, and I'll just use that. Okay, so GraalVM, web, Spring Data JDBC, vector support, Modulith, and OpenAI. I think that's it. Isn't that it? That feels like it's probably it. So let's go ahead and hit generate, and we'll open this up. I have a zip file now, right? UAO service.zip. Okay, and this is up and running. So let's see what we have here. Okay, service application, public static void main, application.properties. We've got some configuration if we want for the application. And of course, our build file containing all the build dependencies that we have, including the version of Java, Spring Data, JDBC, etc. So already we've got something. But remember, our application, we have to connect to the existing data source. So I'll configure the credentials here. This, obviously, I would not do this in a production environment. Keep them in environment variables or something like that. JDBC :postgresql localhost my database. Yeah. Okay. So there's that, and that's it. That's our basic application, right? Public static void main. Nothing too fancy there. Let me make this a little bit big. I don't really know how big should it be, you know? Where should it be? Like, let's do that, okay? So I've got public static void main. Now I want to build an application to manage the adoption process. So I'll create a new module, okay? A new package. So I'm gonna go here, I'll say a new package, and I'll create a new package here called adoption. And what I'm trying to do is to promote modularity in the code base. I have a project on my class path called Spring Modulith. And Spring Modulith makes it very easy to build modular monoliths, right? Get it? Modulith with ease. And it's a very, very powerful project. I like it a lot. And so rule number one is you start being very careful about how you create your modules, your packages. So in this, I'll create an adoption controller, okay? And first things first, I'm not gonna make it public, right? I try as much as I can to never use public. Sometimes you have to, right? But public is an anti-pattern a lot of times, right? Sometimes you have to, I get it, but try not to. And one thing that I see a lot of developers doing is they might have like app.models. Right? And they might have app.services and controllers and model, you know, whatever, right? They'll have these kinds of packages. This doesn't work, my friends. I think this comes from Ruby on Rails, right? It's a terrible pattern. Do not do this because think about it. If you have, let's say, a customer model, and then you have customer service, right? And then let's say you have repositories as well. So customer repository. Well, now in order for them to talk to each other, you have to make all of them public, right? There's a reason that Java does not make types public by default. You're supposed to have, encapsulation, right? Modularity in Java comes from the privacy that you get by having limited scope. If everything's gonna be public, then why even have a namespace at all? Why not just use C, right? C, everything is public, everything is visible to everything else. We don't want that in our Java code. So we want privacy. We want types to be package private or more, you know? And so you can't do that with this. Everything has to be public. For the service to use customer across the package boundary, and then for the service to use the repository, which uses the customer, and for this to use the service, all of these things have to be public, which is an anti-pattern. So in general, whenever I create a new class, I try to remove the word public. Sometimes you have to have public, but in general, you don't want to. And you'll see it's pretty easy when you think about it. So we're going to create a new controller here. And we're going to have an endpoint here. Let's see. I guess this is, we'll do some service kind of things. So we'll make this transactional. And we'll have adoptions, okay? There we go. That's our endpoint. And we're going to have an endpoint here that allows people to adopt, right? So they'll pass in a path variable, integer ID, and then we'll have the request body, right? Map of string of, what is it? String, I guess. Yeah, probably string. Just a payload. It's the attributes coming from the client, right? Which owner will adopt the dog. What we want to do is to support automatically updating the dog's owner attribute with the name of the user. So go here, refresh, public, tables, dog, and you can see here there's an owner column. It's null right now. We want to update this field to be equal to our name, okay? So that way we can adopt this dog. So we're going to have adapt, and we'll have at post mapping. Okay, good. So ID, there you go. Okay, so I'm just going to send in this ID as the path variable. I'm going to do adoptions /ID, and then I'm going to pass in the name of the owner as part of the request body, okay? And I'm going to take that. I'm going to say, okay, let's look for the dog in the database. And I'm going to create a dog repository here. So dog repository, extends list of CRUD repository, managing dogs of type dog, whose primary key is of type integer. So I've got no type called dog. I'm going to define it like this. I'll create a record, integer ID, and the dog itself will have the string name, the string description, the local date of birth, and of course the string owner. Okay, so there's that. And this will be a entity that I'll map to a SQL table. So I'll have the ID annotation. This is from Spring Data JDBC. Okay, so I'm going to use that library. I'm using a nice feature here in Java called Java Records. Right? I love Java Records. These are really nice. Right? They're part of a number of features in Java 21 that support something called data-oriented programming. Right? These are features that, if you take them together, they support a new paradigm. Okay, and these features are sealed types, records, pattern matching, and smart switch expressions. Okay, all four of these things together provide this new feature here. Okay, so what does that mean? Well, let's take a look quickly here, because Java, in its long, wonderful history, Java has served very well in large enterprises with large code bases. They call these monoliths, and in that world, it's very important that you have a fast compiler, that you have the ability to create lots of code, and that you have good, strong encapsulation for those types and so on. But now, as often as we see monoliths, we also see small microservices. We see small network services, and the way that we add new features to the system is not just by extending deep hierarchies of abstract types like we used to do. Nowadays, sometimes if I want to add a new thing to the system, I just send a message, right? I make a network request using a REST or GraphQL or RSocket or Google, gRPC or Kafka or RabbitMQ. It's data. I'm sending messages with data in them from one network service to another. And the way I think about change in the system, the way I add a new change to the code base, is by handling this data. The way this data interacts with the rest of my code is how I add features. And so the language has to be better at solving and working with data-oriented programming, right? And so they've added these features in the last 5 or so years since Java 17. And in Java 21, they finally are all here at one time, right? So let's take a simple example, okay? Just a quick digression from our dog adoption service. Let's create a simple example. Let's imagine that we work in a very heavily regulated industry, like, financial services, right? The government wants to make sure that financial services organizations don't do anything bad. And so there's a lot of law that applies to them, usually, in most organizations, most companies. And so, for example, let's say we have a type of loan, right? A loan for a bank loan, right? Well, bank loans, you have to be very careful because you might have you don't want somebody avoiding the checks and security checks and validations and doing something that might accidentally lose money or something like this. So imagine you have two different kinds of loans, right? Secured loan, implements loan, and you have unsecured loan, right? So a secured loan is a loan with the loan is backed by some sort of asset. The unsecured loan is not. These are more expensive. The user ends up paying more to have this, okay? And these are the two kinds of loans in the system, and each of them has laws that apply to them. So you want to be very careful about how these loans are processed in your code base. But somebody right now, in the system that I have, somebody could create a no-op loan, right? And this loan, maybe it just does nothing. No validation, no nothing, right? And this is bad because now you have a loan, and anywhere in the system that takes a loan could also take this loan. And that loan would bypass all the validation that was built into these. So we can seal the hierarchy. We can make it so that it's impossible to create more types without changing this definition. So I'm going to make this final and final, right? If it's not sealed, if it's not final, the compiler says, hey, the sealed, non-sealed, or final is expected. You can't just have an open type, because otherwise, even though this is sealed, I could go here and I could say class no-op loan extends secured loan, right? And this would be a loophole. It would allow people to extend the system and add this insecure no-op loan, and that's a problem. So I want to seal these by making them final. Okay. Well, the unsecured loan will have a variable interest, right? For example, so I can make this actually a record. Records are sealed, but records are a nice feature in language. In the Java language, they're kind of like tuples. Tuples are carriers of untyped data, right? For untyped data. So you can have, or sorry, for typed data, right? You can have any arbitrary number of components. I can have an int x, I can have a string y, I can have a boolean, whatever, right? I can have all these different components. These are called components, and Java will let you hold them in this tuple called an unsecured loan. Tuples in most other languages don't have loans, but they do in Java, because Java is a nominal language, right? Everything has a name. So this is a unsecured loan. It has one component. This is called a component, and the contract is very simple. If Java knows that you want a tuple, a carrier for data, then it can make it very easy to do that. You just use this very nice syntax, and in exchange, you get constructors, you get field storage, you get accessor methods, right? You get toString equals hash code, all this stuff you get for free just by using this. And the reason this works is because records have no derived state. They have no private fields, only the components that you pass in. And so basically, the identity of the unsecured loan is equal to the identity of the float interest value, okay? So this is a very, very nice, concise feature in the language. It makes it very easy to describe, a data type without having to create all this extra stuff by yourself. If you are willing to make those concessions, then you get a lot of benefits for it, okay? So I've got two different kinds of loans. One has some state, but it's just passed in. It's not computed inside the unsecured loan. And now let's say I want to create a method to display a message, right? String display message for loan. And now I want to create a message. I say var message equals this. And I can say if loan instance of secured loan message equals nice loan, good job, okay? Otherwise, if loan instance of unsecured loan, I can say message equals ouch, and I want to get the interest from the unsecured loan. So I can say var USL unsecured loan, okay? And then I can say that USL.interest rate is going to hurt very bad, right? And then I can return the message. Now, this kind of works, but there's some problems with it. First of all, it's very verbose, right? So for example, here I'm creating a new variable. Well, the language already knows that within this block, that loan is actually a reference to an unsecured loan. So this is called a pattern match, and I can extract the pattern into a variable, right? So that's a lot nicer. I can dereference the interest there. That's nice. That's very convenient. The other problem that we have is if I comment this out, nothing happens, right? The compiler does not care that I have not handled this other case. So I've got two very important paths, two very important use cases, and I'm only handling one of them, and the compiler does not care, right? So I want the compiler to care. So I can use a feature called smart switch expressions, right? And here I can say that the product of each branch in the expression is it's the value that I'll return to the variable here. Okay, so I can now take the code that I had before. There we go, and just replace it with this. Okay, so now instead of doing this, I have just this one branch, and in fact, I can even just return this. I can just inline it. So that's very, very concise, right? I've got just 2 branches of code, and also if I comment this out, excuse me, the compiler says, hey, you didn't cover all the possible input values. So it knows that I have failed to handle both cases. This is very useful because now the compiler is helping me make sure I have good code coverage, right? That way there's no case that's left unhandled. So this is records, steel types, smart switch expressions, and pattern matching. And these things, if you take them all together, they support data-oriented programming, a very, very important, different way to think about programming data and programming software. Okay, so let's get back to this. So I've got a record. When you see me using a record, it's very convenient, but this is not just, look, Mom, no, Lombok. This is not just a better way to do at data, right, like from Lombok. It's actually the beginning of a whole new window, a new opportunity in how we build software. It's called data-oriented programming. Very, very useful. Okay, so now I've got this this method, and what I want to do is I want to take the data here. I'll say private final dog repository. I'll inject that into the constructor, and here I'll say this dot repository dot find by ID. If the dog is there in the database, then I want to update it, right? So I'll say var saved equals this dot repository dot save. Pass this new dog, and I can pass in the dog ID, dog dot name, dog dot description, dog dot date of birth, and then finally the owner. So I'll get that here, right? Name. There's my updated dog. I'm just going to pass it to the repository, and then the result will be here. So system out saved. Okay. Or actually, we can even just say adopted. Good. Okay. Here we are. And so that seems pretty straightforward, right? I think we can try this out. Let's go ahead and run this. Okay, and curl minus d name Josh. Okay, x is post HTTP localhost 8080 adoptions, and then the ID of the dog is 45, right? If you look at the database here, remember Prancer, his ID is 45, right? There it is right there. So we want to adopt him. What did I, oh, I forgot to put quotes. Unsupported, oh, okay, no problem. H content type application JSON. All right, so there we go. That ran, and it says adopted this dog, and the owner is now Josh. So if we go back here and refresh, right there it is. It says Josh. So that worked, right? We've adopted the dog now suddenly somehow, right? Very, very, very trivial code, but you get the idea, right? But this is not exactly representative of real code, right? Obviously, there's going to be more to the process than just adding a field or changing a field in a table. So let's suppose I have another microservice that's involved and that wants to, that I need to be aware of what's happening here. How do I integrate that other microservice? Let's suppose I have another module, another bit of functionality, and that service is called the kennel service, right? And the kennel, you know, in English, a kennel is the like the cage for the dog, but basically a kennel is the place where you keep the animal, right? The house, the home in the adoption center. So maybe this service needs to be involved, right? This service needs to be, maybe this thing should be involved in the process. Maybe you should inject the kennel and then you want to notify it, right? You want to say, okay, kennel, this.kennel dot, dog adopted, right? And then pass in the dog. But of course, there's a couple of problems for this. First, now you've got this detail of your persistence layer, your dog, and you're sending it over to another module. It's violating the encapsulation. But also, you don't need the kennel to do this work. You want the kennel to be notified, but it shouldn't be. You don't need to be aware of it, right? What we want is some way to integrate the kennel without having to be aware of the kennel. So let's remove this from the code here and get rid of that and get rid of that. Okay. And go back to the kennel here, and let's make this not public. Okay. And what we want to do is we want to integrate one module with another. And I think a great way to do this is to use messaging, right? Events. This is a great blog from Martin Fowler that asks the question, what do you mean by event-driven? This blog was released in 2017, and it talks about 4 different types of uses for messaging. One is event notification. Here, one system sends a message to another and tells the other one about something that has happened. It doesn't tell the details. It doesn't send information about what the change means. It just says something has happened. So it's very lightweight, right? You don't send a lot of data. You just send basically the name of the event to the other system. And you can do this with, Kafka or RabbitMQ or JMS or even in Spring using the event bus, right? And this is very nice, but imagine you're over here, you are a separate module, and you get an event notification. It says, hey, a dog has been adopted. Which dog, right? Which dog? You don't know. The event doesn't tell you that. It just tells you something has happened, okay? So in this case, it's not such a big deal. Maybe this other service needs to download all the data about the dogs anyway, no matter what. Even if it knew which dog, maybe it needs to refresh the dog inventory every day, no matter what, right? So it's not a big deal if it doesn't know the ID, because it's going to re-download everything anyway. But the point is, this is nice because the sender of the message doesn't have to send a lot of data to multiple places. But it's bad because the consumer of the message might need to query for the extra data about the event, okay? And that might create a load later on the original sender of the event that it could have been avoided if it had just sent the data in the first place. So that gets us to the next level, which is event carried state transfer. Here, messages are being sent from one module to another. The consumer of that message has everything it needs to act on that message in the event itself. It doesn't need to query the source system to get the information. This is very nice because now, the consumer can act on the data, but it's bad because, of course, you're sending a lot of data. Imagine sending, thousands of messages, each with several kilobytes worth of text data per second, over Kafka. You're now sending, megabytes, hundreds of megabytes of data over the network to multiple systems all the time, right? It gets very, very painful eventually. So it's a trade-off, and maybe the clients don't need all that data. Maybe they just need a little bit. So it's up to you to decide whether you want event carried state transfer or event notification. Now, the event carried state transfer is also very interesting. Imagine that you build your system and you build it such that every time there's a state change, every time somebody adds a record or deletes a record or updates a record or whatever, every time there's anything that happens in the system, you send an event, right? If you send an event every single time, then that means that those records, those messages, those events are a log of your database, of your state, of your system state, right? And the reason we use messaging is because that way we can have multiple modules and multiple services. They can all be a part of the state of the system, right? And there's some interesting opportunities here. Let's say I have 5 different services, and each service has its own database. Well, if I send a message to each service, then they can, maybe I have a search index using Elasticsearch, and it has a full text search index. Maybe I'm using a graph database like Neo4j to do analytics, and it's got a graph database of all your data. Maybe I have a Redis cache which keeps data, hot and available for fast reads, right? Well, if I have all the messages that were ever sent, I can delete Redis, I can delete Neo4j, and I can delete Elasticsearch, set them back to 0, and then just republish all the same messages in the same order. And in theory, I should have the same Redis cache, the same Neo4j, and the same Elasticsearch database, right? Because those systems only change when they get events. And if you have all the events, then you have all of the system state, right? You have the ability to arrive at the same system state. So this gets you to this idea, event sourcing, right? Event sourcing is the idea that my messages are a log of my system's growth, of the evolution of the system. And of course, if you have multiple services that have their own data, right? Redis is for reading. I want Redis to be able to read the data quickly. I want Neo4j to do analytics. I want Elasticsearch to do a full text search. Well, these are all different databases, right? You can't have one transaction across all of these. It doesn't exist, right? And so there's a very obvious understanding here, which is my system is not one single database, right? There's no one thing I can look at. My system is the combination of all these different databases together. And if you understand that some databases are for reads and some are for writes, then that's what CQRS is. It's the idea that we treat different use cases differently. Reads should be optimized for, right? You might have a fully denormalized SQL database over here, but for reads, you want to go to Redis for fast access, right? For cached fast read access. There's nothing wrong with that. It's a pattern. So messaging is very, very useful. We don't have time to get into too much of this, but I do want you to know that Spring has an event bus. It's been in Spring for more than 20 years. It's called the Application Event Publisher, right? So I can add this here. And this class, when did this come into Spring? Java Spring Framework 1.1.1, right? Long time ago. So now I'm going to send a message from one component to another, publisher.publish event. And what event am I going to publish? Well, here is where I will create my first public type, dog adopted event. Okay, here we go. And maybe I'll make this a record, and I'll have the long dog ID. Okay, so that's all I'm going to have. It'll have a little bit of information about the dog, not the details, but just the record itself, and it's public. This is a public type. Okay, so that's what I'm going to export from one side of the system to another. So I'll pass in the saved.id. Okay. Oh, it's a integer, isn't it? There we go. Okay, so I'm going to publish this event. Now, I want to send this event. Who's going to listen to it? Well, I can go over here to my kennel. I can say at event listener, dog adopted, and I can inject the dog adopted event. Okay, system out. We've adopted a dog. Okay. We need to prepare to release the dog to their new owner. Okay, so we're just gonna, we're gonna have this other system that is now aware of what's happening. We don't need this kennel to do our work, but we do need it to be a part of the conversation. So let's try it. Okay, if we go here, curl, hit enter, and you can say we've adopted a dog. Okay, great. Well, it's worked very well, but now imagine I do thread.sleep 10 seconds. Okay. I'm going to restart. Okay, I'll restart. Now I go down here, curl again. Look at that. I hit curl, and I'm still waiting. It hasn't returned yet. I'm waiting 10 seconds, right? So remember, I'm calling the adoptions endpoint, but in my other kennel service, I have to wait for 10 seconds, and that means that the adoptions code has to wait as well. That's not good, right? That's not good at all. So how can I decouple this logic? Because I don't want to have to worry about this, right? I'm letting this service know that something has happened. I don't want to have to wait for it, right? And so one way I can do that is to maybe I can use at async, right? And by the way, if it's async, I also want it to be in a transaction. So I can make this endpoint transactional, right? I want it to start a new transaction since it's going to be async. So what async does is when you add async to a method, Spring invokes this in a separate thread. So the consumer doesn't have to wait. From their perspective, as soon as that thread is launched, they have returned. So it's very quick. This will continue executing, but the original adoption action here will finish almost immediately, right? Let's try that out. Okay, now we go there. Look, it returned immediately, and we're still waiting for 10 seconds. 1 second, my friends. Okay, still waiting. And now we have this message here. It says we've adopted a dog. Okay, so that happened, but it didn't happen in the same thread anymore. And that's a bit of a problem, isn't it? Right? We want to make sure that the kennel gets the message and that they handle the message, right? So what happens if the first transaction over here in the controller, where's my controller here? We want to make sure that this runs and that it completes, but we also need to know that this completes as well. Otherwise, we need to roll things back or we need to handle it somehow. And as things are right now, you could finish the first transaction here, and then you could take the power out from the server and the computer would turn off. And then the other thing would not continue, right? This wouldn't finish. Now what do you do? Or what if there's network latency, or what if there's some sort of error here? So this would roll back and this would not, right? So that's a bit of a problem. We want to make sure that we are handling this event eventually. And so one way to do this is to simplify things a lot by using application module listener. This is from Spring Modulith. And if you look at the code, it's actually a transactional, at async, and it's an event listener, right? Here's that as well. So all three things combined, and it works very nicely with another feature here, which is this one, right? So I can say Modulith republish outstanding events on restart, and Modulith initialize schema is true. Okay, so I'm using two features in Spring Modulith to create a database table that will hold the missed messages. Okay, so you can see now if I refresh here, there's my event publication table. Okay, I want to make sure that when I publish this message, let's restart. Here we go. Republish the message. You go here. You can see it has this table. It has the row, but it doesn't have a completion date, right? So I've got this. Let's wait 10 seconds. Okay, refresh. And now it's got a completion date. So as soon as this message was processed, the completion date was filled out. Now, what happens if I don't fill it out? What happens if I hit enter, I hit refresh, there's a record, stop the program, right? So now there's a record there with no completion date. Okay, let's restart. And you can see where's my kennel? There we go. We've adopted a dog, right? You can see it down here. So now you go back to the event publication, hit refresh, go to the right, you can see completion date is there. Okay, so that's working exactly like we want. We get the best of all worlds. We can use messaging to keep our code clean and modular. We are decomposing, we're disintegrating our two modules so they're not tightly coupled. We get event-driven programming, but we don't have to wait. But also, we get a guarantee that if something goes wrong, the message will get handled eventually, right? Even if you, for some reason, have to restart or whatever. So this is nice modular code base. Now, obviously, I've been showing you Spring Modulith and talking about modularity, but how do you know what modularity means? Well, you can actually test it, right? Application modules .of, and then pass in service application.class. Okay, and you can verify. So this will give me, let me have this here, modules. Okay, let's put that over here. So this gives me, information. I can actually print it out, for example, application modules. I can verify the structure, and actually I can even do something else. I can do new documenter, passing in the modules, .write documentation, right? So Spring Modulith knows whether you're creating modular code that doesn't have cycles in the object graph. So let's run this. I didn't mean to run the application. Let's run this. Okay. So look at that. I've got a green test, right? And it knows that I've got an adoption module and a kennel module. The logical name is kennel, and this one's adoption. It knows what beans I depend on. It knows that Spring Beans kennel, and it knows that this Spring Beans has two beans as well. And it would know what dependencies I've got from other modules if I had some. And you want to make sure that you don't create cycles in your object graph, right? So for example, and you also want to make sure you don't leak implementation details. So let's say I have a package private implementation detail. So I want to create some code for validation. Okay, so I create a new class, validation, and it's public. It has to be public because I'm in a sub package, right? I'm in adoption.validation, but I'm only going to use validation in this controller, right? That's where I expect to use it. But maybe I accidentally go here and I say private final validation, right? Well, now I've got an object from this module that I'm injecting into this one. So it's going from adoption to kennel, and it's a nested package. It's not the root. The root types usually are public, or they're user facing if they're public. But in a sub package, that's usually considered an implementation detail, right? Good architecture tells you that that should be package private. You don't want to expose that to somebody else. So let's go ahead and run this test again. And you can see the test is broken now, right? Because if you go here, module kennel depends on non-exposed type validation within the module adoption, okay? So this is a problem, right? We've exposed this package private detail, and Spring Modulith has helped us catch this, okay? So let's fix our bug. Obviously, I don't want to inject that, okay? And then we rerun the test. And the test is green again, all right? Very good. So Spring Modulith has a way to help you understand what the structure of your system is. And in fact, it knows what the structure of your system is, and it can even help you document it. So when you go to the build here, you can see it generated a C4 diagram. This diagram shows you the component boundaries of your system. This is living documentation, right? And so I can go to module kennel. I can see that this depends on that. Module adoption, etc. Right? And here's the it gives you ASCII doctor descriptions of things, right? So base package is listening to this dog adopted event, right? It's all generated for you automatically. So now, if your architects are wondering how the system is coming together, just hand them that documentation, right? The system is automatically documenting itself because we have an awareness of how the system is built and structured. Okay, so we've got a modular code base. We've got clean Java 21 data-oriented programming. We've got modularity. We've got living documentation. We've got messaging and decoupling. I think we're doing pretty good, but we still haven't really solved the hard part, right? We were able to adopt Prancer, but how do you find Prancer in the first place? You and we all saw the data in the very beginning, and we said, oh, there's a dog named Prancer. His ID is 45. So let's adopt Prancer. But what if I didn't know the ID, right? How do I find Prancer in the first place? And here is a very good use case for AI, okay? So let's create an assistant to help us find this dog, okay? Or any dog, really, but configuration. Okay, and what we're going to do is we're going to use the Spring AI chat client to talk to a chat model, okay? In this case, the chat model is the it's OpenAI, right? Or it could be Olama or whatever. So I'm going to use the chat client. I'll build an instance here. in order for this to work, of course, you need to configure how to connect to your model. So I can use OpenAI API key. I've already done this, my friends, off screen. Before I came on screen, I already set up an environment variable with my API key. And it looks like that. And that gets turned into this, right? Spring AI, OpenAI key. So I'm not going to share my API credential. Please forgive me, but just trust me, it's been done. What I have not done is specify the model, right? So model, there we go, chat options model, GPT-4o, okay? So that's the model in OpenAI that I want to use. So now I'm going to go back here. I've got my chat client, and I'm going to create an assistant that uses that chat client, right? Right, like that. Demo, assistant, right? And we'll inject the chat client. Here we go. Okay, so let's say I want to ask it for help finding our dog, right? So the prompt, the user prompt, will be, do you have any neurotic dogs, right? And we'll ask it cc.prompt.user user prompt.call, and then we'll get the content back as a string reply, okay? And then we're going to print it out. Reply. Okay, so we're going to run that. Let's see what happens. Let's go ahead and restart this program. There we go. Oh, okay. Okay. So I've gotten a response, and it says, as an AI, I don't own pets, but I can certainly provide information and advice if you're dealing with a neurotic dog. So, okay, we understand, right? It gave us a response that is not what we want. Remember, we're trying to pretend that we are a dog adoption service, right? This is a service that can help you find and then adopt dogs. But this doesn't know, the AI doesn't know about that. It's just an AI. It says, hey, I don't have pets. I'm just an AI, obviously, right? Like, this is an understandable response, but it's not the one we want. It's not a good response. And so what we want to do is to get the AI to act like it is a representative working at our dog adoption service, okay? So what we're going to do is we're going to give the AI a system prompt, okay? Default system prompt. And that system prompt, I'll put up here. And I'm going to copy and paste it because it's very long. And this is not about programming. This is just English language, or you could use whatever language. Obviously, Arabic is fine too, of course. But any language, here we go. So there we go. So you're going to say, you are an AI-powered assistant to help people adopt a dog from the adoption agency named Springs Pet Emporium, with locations in Barcelona, Spain, and Madrid, wherever. You could actually put other cities. You could put Riyadh in there if you want, right? If you don't know about the dogs housed at our particular stores, then return a disappointed response suggesting that we don't have anything, okay? So you're going to teach the AI what it should act like. Okay, so I'm going to pass this in there, and then we're just going to rerun. We've only given it a default system prompt. I could also specify a system prompt here, right, for each request, but usually it's a governing thing that you just specify once. Okay, so we restart, and it says, hey, I'm sorry, but I currently don't have any information about specific dogs housed at Springs Pet Emporium. However, you're welcome to visit our locations in Barcelona or Madrid, or contact us directly for more detailed information on the dogs available for adoption. We'd be happy to help you find a pet that matches your needs. Okay, this is better, right? It doesn't have any useful information yet, but at least it's acting like it should. It thinks that it should. It's acting, if you're typing into a chatbot on a website and you get a response here, you might think, oh, this is just some person in front of a computer, and maybe the computer's down right now, and so they're saying, like, oh, I'm sorry, we don't have anything right now. I can't, I have no information, right? This is much more personable. This is, and they mentioned Springs Pet Emporium. and so on, right? So it's acting like it's a representative from our organization, our group, our effort. Okay, so it's better, but clearly it doesn't know about our data. It doesn't know about the dog table here, okay? And so what I want to do is I want to teach it about that by integrating it. And so remember, most of the work of AI these days, AI is all about integration, right? Integration of two things, integration of APIs and data, right? If you can integrate these two things, then you're going to be in business. Most people do not need to create their own AIs, just like most people don't need to create their own SQL databases. You talk to the SQL database, you don't build the SQL database, right? And so here it's just an integration game, and Java is very good at integration, very, very good at integration. It's what we do best, right? It's why Java is so popular, is because it works with everything. So how do we support this? Well, we want to support something called RAG. RAG, okay? This is retrieval augmented generation. And what you're doing is you're taking data from your database and you're adding it to the request and then using the data in the request to give the AI some context so that it can answer the question better, okay? And so it's not hard. You just have to do it. And so Spring AI, the project that we're using, Spring AI, right? Spring AI is very good at this kind of thing. So let's do it. Let's actually, first of all, integrate data into the vector store. All right, well, so we need to get the data into the LLM in the request to the LLM, but we don't want to send all the data, right? We've got lots of records here. Well, only 18, but we have, you could have like 1 million records, and only a few of them will actually match. So what we want to do is to have a staging area. This is why we're going to use a vector store. There are many different kinds of vector stores, right? Vector stores including Milvus, Postgres, pgvector, Neo4j, Elastic, Search, Redis, Weave8, Chroma, DB. There's a dozen. There's at least a dozen. There's like just every day it seems like there's a new vector store, right? In fact, Spring AI has a vector store in memory. Here's our vector store. This is the entire implementation. It's 251 lines of code. And the reason it's so easy is because it's mostly just very, very simple math, right? It's just a cosine similarity, right? Where's the actual? Here, you're doing a search across a vector space, like mathematical vectors, looking for using cosine similarity to determine if this matrix of numbers is similar to that one. Very, very simple stuff, right? Not too hard. Anybody in high school math could write this code themselves. And so this actually comes in Spring AI. You could use this for simple toy examples, but I wouldn't, for anything in production. But that's okay because we have implementations of vector store for like a dozen different technologies. The one that I'm using is the one in Postgres. It's the pgvector extension. So we're going to use that. So I'm going to inject the vector store implementation that Spring AI has created for us, right? Take all that. Vector store. And of course, in order to get the data from our dog repository, we'll need to read it all. So we'll get the repository, find all for each dog. We're going to create a document. Okay, new document. And we're going to pass in some content, name, ID, description. Okay, formatted dog.name, dog.id, dog.description. And then we'll have some metadata here as well. So map.of dog.id, dog.id. Okay, so we're just passing in some data about the dog, and we're going to add this to the vector store so that we can then do fuzzy similarity searches in the vector store. Okay, so we'll say vector store dot add list dot of document. Okay, so we're adding that. And now it's in the it'll be in the vector store. By the way, this takes a little while to do. It actually is pretty slow, and the reason is because it has to calculate the embedding, and that involves a lot of like very GPU and CPU intense work. This is why so many chip companies are very popular right now, right? Because of this this need to be able to crunch this kind of data. Okay, so now I want my AI pipeline, my chat client, I want it to know about this data. Well, this is easy, right? Remember, this is Java, right? We have a very nice language here. This is not like PHP where you can write lots and lots of code and get no results, right? This is very easy to understand code in Java. So vector store, and then I'm going to provide a search request with the defaults, and then that's it. It's a question answer advisor. Okay, this supports the RAG pipeline, right? That's all, one line of code. I woke up this morning and I said, I want to write a RAG pipeline. I wrote one line of code and I got a RAG pipeline, right? Okay, so let's go ahead and run this code. There we go. Oh, by the way, this is a document about dogs, so obviously it should be a document. Okay, look at that. It ran. It wrote everything to the Postgres. It says, yes, we have a neurotic dog available for adoption. His name is Prancer. His ID is 45. He's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. If you're interested in adopting him, please let us know. Nice, right? It worked. So let's comment this out. We don't want to reinitialize the database twice, Also, I've been initializing the SQL database each time I start the program, but we don't need to do that. So don't do this anymore. And vector store Postgres, PG initialize the schema is false. Okay, so I'm not going to initialize the tables anymore. So this took 1.491. I've disabled the schema initialization, and let's try it again. Okay, 1.2 seconds. So I saved like 300 milliseconds, and I got the same response or something similar. Okay, so now we have a much faster service. This is free-form text, though, right? Maybe I want actual data. I want like an object that I can pass around. So let's create a dog adoption suggestion. Okay, integer ID, string name, string description. So I want the AI to give me the response, not as a string, right? Here, the response is a string. I want it to give me an entity of this type. And if I do that, the return value is dog adoption suggestion. The type that I have there is this. It's dog adoption suggestion. So I'm going to, let's just print out the results, right, like that. Let's go ahead and restart. Okay. And there we go, dog adoption suggestion. The ID is 45, name is Prancer, and the description, a demonic, man-hating, animal-hating, children-hating dog that looks like gremlins. So the AI, the Spring AI, added some JSON schema to the request for you that told the AI that we want the data to come back in the shape that looks like this, right? And then we convert it into the JSON. We convert the JSON back into a Java object for you, and we send it back. So it's all transparent. It just works. Okay. All right. So now we have a nice API for finding, and you can easily now that we have the dog adoption suggestion, we can get the ID, and then we can call that first service that we just built. I think we're ready to go to production, don't you? I think we're in a very good place. So let's quickly think about what we want to do to make this go better in production. First things first, I want this to be scalable. Right now, I'm making these network calls to the AI, but each time I do that, I am blocking a thread. You know what blocking threads are, right? Like if let's just imagine I'm here. Example, if I do, let's say I have an input stream, right? I'm reading data from a network socket, okay? Just to do, and I say while var next equals -1, while next equals in dot read -1. So this is basic Java code to read and do I/O, right? Let me just more actions. I'm okay. If now, Whoa, that was confusing. Let's just, let me just put try catch around that. Okay. Right? Okay, there we go. So I'm doing a loop. I'm saying read each byte from the input stream, and as long as it's not -1, then I can write it out. Okay. Well, what happens if this is a network socket? If I'm reading a byte from a file system, then it's probably going to be really, really fast because SSDs are fast and the local file system is local and it's quick to get to. But if I'm reading a byte from a network socket, well, that service might disappear. It might go down. We might lose internet on my data center, right? So I don't know when this is going to return. And if I call .read here at, if the time is 10:05 a.m., whatever, if I call that, there's no guarantee that this will return quickly. It might be 11:05 by the time I get to this line, right? This might never return. And the problem with that is that in order for me to make that request, I have to be on a Java thread. I'm on a Java thread right now. And that thread is not being used for anything else. I'm just sitting there, taking it and monopolizing it and not letting anything else in the system use it. Wouldn't it be nice if it was possible to just transparently turn that off so that it would automatically jump off the thread and then let somebody else in the system use it? Well, you can do that now with Java 21. We have this amazing, amazing feature called virtual threads. If you want to enable virtual threads in your Spring Boot program, just enable this property. That's all you have to do is spring.threads.virtual.enabled, and we'll configure virtual thread pools for you. So how good are virtual threads? Well, it's very hard to generalize, obviously. But I saw a really good demo. My colleague, her name is Cora E. Berkeley, right? She's super smart, way smarter than I am, and she has a great demo that I will show you here. Okay. At controller, at response body class. So we're going to have a delay controller. Okay, and this controller, private, it's a delay controller constructor. We use the REST client. Okay, dot builder, and it'll be private final REST client. RC. Okay. Get rid of that. Builder.build. Okay. So I'm going to create a simple controller that uses a blocking REST client. Okay. So it's going to wait for the response to be generated, and we'll invoke it, and we're going to use it to say this.rc.get URL, and we're going to call https http-bin.org delay 5. We'll get the contents as a string and then return that. So .class. Okay, so this URL, if you don't know, if you go here, this URL is a great way to test services or clients, right? This HTTP endpoint will wait for 5 seconds, right? Because I passed in 5. If I put 1, it'll return after about 1 second, right? There it is right there. If I put in 10, it'll return after 10 seconds. You get the idea. It blocks for however long we ask it to before it returns a response. So here, I'm going to ask it to wait 5 seconds, okay? So this is going to cause network I/O. Also, this is a Spring MVC controller. So I will have my own client that will, a command line client that will do load testing on my service, and it will in turn call this other service. So let's go ahead and restart. Okay. And now I'm going to drive some traffic. K minus n is 60 requests, 20 at the same time to localhost 8080/delay, right? So that's I'm load testing my controller, and each time my controller gets invoked, I make a call to this other network service. Okay. So this is with virtual threads. Let's see what that gives us. Run that. So this should take, a few seconds, not too long. Okay, so here's the, it's 18 seconds. Okay. It's 18 seconds. So with virtual threads, it took 18.9 seconds, almost 19 seconds. And the slowest request was, oh, you know what else I forgot to do? I forgot to limit the number of threads to make it more fair. So here, let me do Tomcat threads max equals, let's say 10. Okay. Sorry. Let me restart this with the limited thread size. Okay. So now if I go here again, ignore all that. Let's try that again. Okay. Wait for it. So again, I'm creating an arbitrary, because most servers aren't going to have the number of threads that you have on your laptop, right? I'm running a very, very powerful MacBook Pro. It's fast enough to run Slack. It's a very, very powerful machine. So I limited the number of threads so that we can see what it looks like in a more realistic example. So here we go here. Almost 19 seconds. The slowest, remember, each request takes 5 seconds, right? Because I call the endpoint and the endpoint calls HTTP bin, and that request is going to be at least 5 seconds and some change. Well, it looks like the slowest, there's only 10 threads and we've got 60 threads, 60 requests total and 20 concurrently. That means that even though we've got only 10 threads, we've got 20 threads where the client is sending 20 requests at the same time. So we're going to be missing 10 threads. We don't have enough to keep up. So some threads are going to have to wait, right? But it looks like the queuing that the virtual thread system is doing is pretty efficient. So most threads are not waiting more than 7.31 seconds, right? In fact, the fastest, I don't know how, is 0.4 seconds, right? What is that? Is that an error? It's got to be an error, right? Surely. Oh yeah, there's an error, 500 code. Let's try it again, okay? Ignore this. Yeah, the fastest should not be faster than 5 seconds. Obviously, it should be 5 seconds and some change. So we'll start again. Okay, almost there. Okay, there we go. 2 responses in the 500. Why? Is the service that I'm calling bad gateway? Are we sending too much traffic? I guess. Let's try 40. I mean, I don't care. It's just some low number. The service that the HTTP bin, which you're supposed to use for testing, is actually failing right now. It's throwing off our results. So maybe it's just mad at us for sending too much traffic. There we go. Okay, there we go. So I sent 40 requests total with 20 concurrent. Okay, so 20 requests at a time. And so it took 14 seconds total. The slowest was 7.1 seconds. Okay, so a little bit worse than 5 seconds. The fastest was just over 5 seconds, and the average was 5.7. That's pretty good. Call it 5.8. Round up a little bit. Okay, pretty good. So that's with virtual threads. Now let's see what happens if we don't have virtual threads and the runtime is automatically blocking. Okay. If we don't have virtual threads, then the code will just sit there and there's no way for anything else in the system to use those threads. So let's try the same request again, 40 and 20. But we've disabled virtual threads here. Okay. Taking a little bit longer, you can imagine. Yep, okay, there we go. All 200, that's good. Where's our data here? So without virtual threads. Okay, so the total time for all the requests was 10 seconds longer than with virtual threads. So already huge win, right? Virtual threads allows more efficient time sharing. And so as a result, things are executing more often. And so you don't have this queuing problem that results in almost double the wait time, okay? The slowest thread was, oh my goodness, 19 seconds, right? The slowest here was 7 seconds. Remember, each request should ideally, if there's enough capacity, take 5 seconds. The slowest was 19 seconds here, right? The fastest, yeah, the fastest is basically the same, 5 seconds, 5 seconds. The average was 8.8, right? Versus 5.7. So you can see just in general, oh, the request per second, 1.6 versus 2.8. So you can see virtual threads is much faster. The average is better. The number of requests per second is much better. It's almost double. The 99th percentile is terrible if you're using no virtual threads, right? Look at that, slowest, 19.4 versus this, which is 12 seconds faster, right? It's just a much better deal to use virtual threads. And all you have to do to enable it is just set that property. It's a free thing that the Java team has given us. It's free scale. You deploy, now when you make those network calls to OpenAI and to the LLM, it's not blocking, right? It is blocking, but you don't care. It's cheap now. The cost of doing it has been made almost nil thanks to the power of Java 21 and virtual threads. This is a huge, huge deal. And I am so thankful to Oracle and the Java community for making this possible, right? Huge, huge numbers. Okay, so we've got virtual threads, free scale, right? Free scale. Nobody likes to burn money. Nobody likes to spend money and lose it for no reason. If you set up this property, you can have more scale for less money, right? It's a very, very nice situation. What else can we do to make this service faster and more scalable and better? Well, maybe we can turn it into a GraalVM native image. And in order for that to work, I need to register our dog adoption suggestion because we're going to do reflection on it. Okay, we're going to use GraalVM. GraalVM is a way to create native operating system and architecture specific binaries that run really quickly. Okay, so I'll go here and I'll do Maven skip tests p native compile. I'm going to let that run. Now that's in the background. That's going to create a GraalVM native image. I love GraalVM native images. I love the technology. I love the ecosystem. It's just an amazing technology. But the only problem, of course, is that it's Java. Java is very, very fast and very scalable, right? But sometimes it's at a cost. I mean, actually, have you seen this 1BRC competition from earlier this year? This asks the question: how long or how quickly can you parse 1 billion rows of CSV data, right? Of weather station telemetry data, right? So it's a billion rows of text in CSV format, and it's like 13 gigabytes of data. And they asked, this is Gunnar Morling. He's another Java champion like me, and he said, you can do anything as long as it's using regular Java, nothing, no libraries, no class path, just JDK, right? Any JDK though, you can pick. And you can have your own startup script and all that. And so there's hundreds of different entries here from different people. And they all got ran on the same machine against the same workload, right? And they were timed. And the results are amazing. And actually you can see where's the fastest one? Here. The fastest one was in 1.5 seconds. So the program, you hit enter, it loads 13 gigabytes of data like this, does some statistics, prints them out, and then exits in 1.5 seconds, right? That's amazing. Java is amazing. It's really, really fast, right? The only thing that's interesting here, though, is that most of the top three are all using GraalVM. So if you really want fast startup time and you want very efficient memory usage, GraalVM is really good. But Java is also pretty good. I mean, you can see number 4, not quite as good as number 1, but still very, very similar, 1.8 versus 1.5, right? And it still does it, and it's just using regular Java. But still, I like GraalVM. GraalVM is very efficient, very fast, very memory efficient, right? And by the way, this is very important. I think the environment is very important, right? So, and Java, of course, is very energy efficient. It has always been very energy efficient. There's this wonderful blog from 2018 that asks the question, which programming languages use the least electricity, right? And you'd be surprised by the results. You can see here that C is the most energy efficient, Rust, number 2, C++, tooey, disgusting. We got Ada, who cares, and then Java, right? Java is number 5 in the list of the most energy efficient languages. So it's already very, very good. But with GraalVM, it gets even better. So I'm a big fan. The only problem with GraalVM, of course, is that it just takes a long time. The compilation takes forever, and I get bored very easily. So I went to the GraalVM team and I said, I already hear elevator music in my head when I do these long-running compilations. I'd just like everybody else to hear it too. Please, thank you in advance, and I appreciate your amazing work. And I got some great responses. But my favorite one is this one. This is from Dr. Fabio Niephaus. He's a doctor on the GraalVM team. He's a PhD graduate on the GraalVM team at Oracle. And he responded, he said, "Thank you for the feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption." Go on. Anyway, he continues, "I have prototyped a -- Josh Long mode. So what this would do is that it would print out, you would run native image, that's the compiler. It would print out music brought to you by Josh Long. And of course, you would hear music, right? Obviously, this is a picture, but you can imagine there's music, right? You're running the GraalVM compiler, you're hearing music, you're wondering why this is happening, who did this to you, and then it prints this out. You would see a picture of me. And I think this would be a great addition to the GraalVM compiler. I'm sure they will merge it soon, but I don't know when. I forgot what we were talking about. Oh, right, the compilation. Right, okay, so there it is. This finished after about a minute. So that was done, let me see, that finished at 12:34. No, wait, that's not 12:35. 12:12. It's now 12:16. So that finished 4 minutes ago. That's very embarrassing. That finished a long time ago. Let's run this. Oh, okay, first problem. The port. I've already got the port running. There's something running on that port. There you go. So there's the application. You can see I got the dog adoption suggestion. Prancer, ID 45, demonic, neurotic, man-hating, animal-hating, children dog that looks like gremlins. The program started up in 0.1 seconds, right? A tenth of a second. And most importantly, my friends, it's using a very, very little RAM. So here's this, PS-O, RSS. Here's the RAM. This is measured in kilobytes, right? So you divide by 1,000. So 135,000 divided by 1,000 is 135, right? So it's 135 megabytes, right, of RAM. That's how much this is taking. For reference, I'm using StreamYard in the browser here. This StreamYard tab to stream this session is taking 387 megabytes of RAM, right? Just as one browser tab. If you go to the news, if you go to different news websites with lots of text and pictures and all that, you can easily get Google Chrome to waste more than a gigabyte of RAM. No problem, very common, right? And yet here we have a super smart service that uses AI, that's modular, that's blazing fast, that has nice language syntax, that has a web server and AI and data access and ORM and vector quantization, all this kind of stuff for, a tenth of that. We live in an amazing time, my friends. There's never been a better time to be a Java and Spring developer. I hope I have persuaded you of this. I want to thank you for spending the time with me. I know we ran a bit long. I apologize, but thank you so much for everything, and I'm happy to answer questions now.
Thank you so much, Josh, for this amazing presentation. We have a couple of questions here, if you don't mind.
Sure.
The question here is saying, I think you have demonstrated that using the OpenAPI keys. So can you please give us how to get these keys from where, and is it free or there's license?
Well, OpenAI is not free, I don't think, but you can use Ollama, right? Ollama is free. Like I said, there are different models. You don't have to use OpenAI. You can use Ollama. You can use Google Gemini. You can use anything from Hugging Face. You can use, countless different modules out there. There's some in China that are very popular that we have support for as well. The model that you use is up to you. It's like a database. It's like, do I want Postgres or MySQL or Oracle or SQL Server or whatever? Here, I just logged in to my API login and I generated a key. And I think I pay them, I don't know, $10 a month or something like that, maybe $20 a month. It's not cheap, but it's definitely possible. If you don't want to do this, though, because of privacy concerns or whatever, like I say, it's very easy to use Ollama, right? Ollama is like Docker. It's like a Docker machine for different language models. So we were using Ollama, and I showed you Llama 3 earlier when I generated that poem. Llama 3 is an open model. You can download it and use it for free in your data center. Nobody knows, nobody has to pay. It's completely free, and it works on your local machine. You can deploy it to your production environment, etc. So yeah, the choice is yours. Just make sure to configure Spring AI to use the right, URL and most important, all that.
Yeah, thank you so much. So
Thank you.
that's pretty clear. The second question is that when we use the Spring AI, like, is it similar the way that we use the LangChain for J, or there are some completely different things?
It's similar in the scope. That is to say, Spring AI is a great project for working with AI engineering patterns, right? So RAG patterns, for example, and integrating with models. And we also support embedding models and image models. And this is a chat model that you saw me using today. But we support a lot of different models, and we support a lot of different embedding clients, a lot of different image models, and we also support a lot of different vector stores, and we support a lot of different patterns, right? Including the RAG pattern. But it's a totally different approach. LangChain is not even in the Python world, LangChain is not very nice, right? I like Llama Index a lot more, for example, in the Python world. So I think they have a bad reputation for building stuff that they then have to throw away or refactor completely because it wasn't really, I didn't like it very much. I think Llama Index is a better code base, but that's only if you're using Python. If you're using Java, Spring AI is awesome. Try it out.
Okay. Do we have something for Llama Index for the Java engineers, or we have Spring
Just
AI?
use Spring AI. Spring AI is the closest to that.
Nice.
It's
so, from your experience in the market, like in the worldwide, in the world, like especially in the production markets, so do they use like Spring AI or something else?
So Microsoft. Okay, where do I start? Microsoft has a enterprise customer base, right? So Microsoft Azure is the cloud platform for Microsoft, right? And Microsoft Azure runs a lot of workloads against their hosted open AI instance. So Microsoft has a very big, lucrative deal. Microsoft invested billions of dollars into open AI, and as a result of that, open AI lets them run a private enterprise version of their model of OpenAI. The same model that's behind ChatGPT. They run that on Microsoft data centers, in Microsoft data centers on Microsoft hardware, and so they have a product that you can pay Microsoft for called Azure OpenAI. And so this is if you have an Azure account and you've already got it in your organization and you've got cloud infrastructure spend and all that, and you want the same OpenAI API, but you want it hosted and managed by and paid for through your Microsoft Azure, then you can use that, right? So already, I think it's like half, it's some really good number where a very large number of the users, I forget the exact number, a very large number of the users there are using Spring AI. If they're using Java, and a lot of them are, right, because it's the enterprise, then a lot of those people are using Spring AI, right? So it's already very popular, very, very ubiquitous there. I just did a keynote a few months ago for Google Cloud Next, and it's like a 5-minute keynote. I was up there with Vercel and a few other people. You can watch the video online. It's the second day developer keynote, and it's streamed to 2 million or so people. Maybe it's more, maybe it's less. I forget, but a lot of people saw the live stream. So it's Google's big keynote, right? Their big conference keynote, and the message there was Spring AI, right? They didn't bother with anything else. It was just it wasn't even in Python. They're going after the enterprise, right? And so you saw we had Vercel's the JavaScript company, and then I was there from the Spring and Java side. So Spring AI is very, very popular. I don't know how to give you more concrete numbers yet. It's not even GA yet, by the way. We're working on that. and I'm hoping for a milestone 2 release sometime soonish, but I can't give you exact dates, yeah, it's definitely very, very, very popular. It's one of the most active. It is the most. It's probably the most active Spring project already at the moment in terms of like new pull requests and new ideas and new code being added to the code base all the time. It's white hot.
Yeah, thank you so much. I think this is really does the answer the question. I think from the post we don't have any other more questions, so I think we are happy, really happy to see you here in our jug, Josh. It was really pleasure meeting you and really pleasure having you here in our project. I really promise you to host you here more and more. We really enjoyed. It was really informative session.
Thank you so much. I wish I could be there in person, maybe someday. And yeah, if you're on YouTube, find me there, and thank you.
Yeah, sure. Thank you so much, audience. Thank you so much again, Josh. See you.
Bye, everybody. Thank you.